Hello, welcome to Maths with EJD. In this video, I'll be talking about numerical computing with NumPy. NumPy is actually one of the packages in Python for numerical computation. And of course, just like I like to start from here so we can navigate our way through to where the document is. So today it's like the eighth video in this series on scientific computing with Python. So as usual, I share my screen and okay, then I come to the search bar. And because I always use Jupyter Notebook, it's always there. If it's not there, you can search for it. So I click on this. Of course, that's after you have installed Jupyter Notebook through Anaconda. All right. And of course, this terminal comes up and you're tempted to close it. Don't ever do that because it is the brain behind whatever else you'll be doing in Jupyter Notebook. Interestingly, because I know that that anything about coding, it's better you do it hands-on. So I've generously provided the notes to every class to every video I've made under scientific computing with Python, and you can check the description box to see the links. I mean, the link to the notes. Okay, so coming here now, it shows you all the folders you have on your computer, and you just navigate to where you have your the Jupyter notebook you want to use. So mine is on the desktop in a folder called Scientific Computing with Python. And of course, today is about numerical computing with NumPy. NumPy. So apart from the inbuilt, yes, okay, in the last video I did, right? I was talking about functions and modules. So, there are inbuilt modules in Python, but then there are external ones like NumPy, or, module or, packages like that, uh, or libraries, if you like. So they help you to do specific tasks. So in the case of NumPy, right? NumPy is numerical Python. And interestingly, Python is so interesting that whatever you do, whether you're into accounting or bioinformatics or anything at all, there's a Python package for you. So all you just need is to check for the Python package that works with your particular area of specialization. Okay. So talking about numerical computing with NumPy, like you already know, NumPy is numerical Python and is a powerful library in Python used for numerical computing. And it provides support for large multi-dimensional arrays and matrices, along with a collection of mathematical functions to operate on these arrays efficiently. Now, you see, previously we had talked about Python variable data types and then Python variable data structures. Those should be like the second and third or third and fourth videos if you check, and you see there that we're able to work with lists and tuples and all of these things, but they are just one dimensional. But when you want to work with matrices, which are two-dimensional, you need to use NumPy. And the added advantage of NumPy is that you can actually do, for instance, for those who are into data analysis, right? You can do some mathematical calculations on a whole row or on a whole column of a data set, even if there are 1,000 data points or 1,000 items across the row, depending on what exactly you are doing. So that is the usefulness of NumPy. So NumPy has the strength with arrays, matrices, and things like this. Okay. So NumPy's flexibility and efficiency makes it an essential tool for numerical computing and data analysis in Python. Of course, when we talk about scientific computing, it's a combination of things like numerical computing, things like well, of course, that's scientific computing, right? And of course, along the line, we're talking about symbolic computing. So as you're going to see as we go on. All right. So of course, if anytime you have a library or a package like NumPy, the first thing you want to do is you want to install. How do you install in Python? Generally speaking, to install any package or library in Python, you need to use pip install, then you put pip space install, then space, then you now put the name of the library or package you are using. So that's if you haven't already installed NumPy, you can do so via pip, and that is why you have pip install NumPy. Of course, I have it installed, but I mean, for your sake, I'll just still run it. The only thing is that it will tell me that the conditions requirements for NumPy are already satisfied on my machine. Okay, so it takes a bit of time, and then it tells me something. But if it's so, it may take a longer time. If it is your first time of installing. Okay, so you can see requirements already satisfied. And it says you may need to restart kernel, the kernel to use updated packages. So I don't have to worry about that. So that's installation. So to install any package or library in Python, mostly you get to use pip install NumPy, pip install SciPy, pip install SymPy. For those who do data analysis, pip install pandas, and so on and so forth. And of course, when we get to visualization, so pip install matplotlib, pip install seaborn. Those are the kind of visualization stuff we are going to be using. All right. So let's talk about importing NumPy. So so you can installing NumPy means you have it on your computer and you can access it. But each session of Jupyter Notebook you open and you need to use NumPy, you need to import it. So importing it is like calling it, like saying, I need you now, please come. That's the idea of importing. So each session of Jupyter Notebook you open or whatever else it is, you have to first of all import NumPy. And to import NumPy is for you to register it for use. Because if you don't import it, and okay, for instance, to import NumPy here, you have import NumPy as NP. So interestingly, what you're actually importing is NumPy. But as NP, this NP is the alias for NumPy, meaning that normally when you have something like this, like we saw under modules too. So for you to use square roots, you have to call square root from the math module, the math module, or if you need to use file. So that's why you say math.py, math.sqrt. And so it means that if you want to do the same for NumPy, you have to say if you need to use something, maybe any function inside of NumPy, you have to say NumPy dot that thing. But in case you have, of course, NumPy is pretty short, so it's still manageable. But by standard, right, we just give it an alias. So instead of having to say NumPy dot something every time, you just say np dot that thing. So that saves you a bit of time, trying to do that. For instance, here, if you want to use array here, array comes from NumPy. So to import NumPy as NP, you have to run this cell. So this blank box beside this cell shows that I've not run it. So if I come here and I try to do this, it is going to tell me it's going to give me an error. So if I run this now, it just gives me an error. You see, it gives an error. It says name NP is not defined because it says NP. Okay, let me put the line number so I can easily refer to them. So here, there's NP in line 2, np.array, and it's wondering what is NP. Now, the reason for that is because I have not imported NP here. So you have to import NP by writing import NumPy as NP in the cell and running it. Good. Now that you have a number beside that now, it means that it is registered. So it means like you have mounted NumPy for use in this session that you're in, right? So if you now go to creating NumPy arrays, just like we said already, NumPy is very good with arrays and matrices and things like that are two-dimensional, as opposed to inbuilt Python data structures that are just one-dimensional, And of course, if you even want to make them two-dimensional, they are not that powerful compared to NumPy. Okay, so coming to 3, we have creating NumPy arrays. How do you create NumPy arrays? NumPy arrays are the core of the library. So basically, array is the basis of NumPy. So you can create arrays in various ways. So the first way to create an array is you can create an array from a Python list. Of course, you already know what a Python list is. It is defined by square brackets. You can actually create an array also from a Python tuple like that, So you can also do that. So here you just say my list is 1, 2, 3, 4, 5. That is, so you see that my list is a variable name for this Python list containing numbers 1, 2, 3, 4, 5. And then here now, you want to turn it into a Python array. To make it into a Python array, just say a new variable name arr equals np.array. So this array now is a function inside of the NumPy library. So, and you now call my list. So you're saying make this Python list into a NumPy array. So by running this now, so this line 3 automatically converts this list into a NumPy array. So you can now print the array. Of course, the array still comes out like what you have in NumPy in Python list normally, but it's actually not the same. So what if I come and I say, so like I told you, you can also make a tuple into a Python array, into not a NumPy array rather. So here, if I just say my tuple, and of course, a tuple is defined by, in case you don't know what I'm talking about, this is what we did on the video, when I made the video for Python variable data structures. So we talked about list, tuples, dictionaries and sets. Of course, I didn't really talk about dictionaries that much, but I talked about sets, tuple, and list. So here you just come and say, uh, you can say, you can just say, okay, well, let's just say AR, right? This is the new variable name. And you say np.array and then my tuple. So it means you want to convert a Python tuple into a a NumPy list. So you just print the AR now, which is the list, the tuple you have converted. So if you do that, it just gives you something like this again. So you see, so Python tuple, a Python list is usually defined, a Python array rather, especially one dimensional, is usually defined like a an inbuilt Python list, something like that. Okay, so you can actually create a NumPy array from a Python list. So the next thing you can actually use np.arrange, that is np.arrange, that's single R now. So, or should I say np.arrange, something like that. So it means a range is actually a function inside of the NumPy library. So if you now say arr equals np.arrange 0, 10, 2, that means start from 0, stop at 10. But of course, you don't get to 10 like we said already. So if you are moving from 0 to 10 in Python, in this kind of case, you start from 0 and you stop at 9. Okay. So it's more like this is 0 to 9. So start at 0, stop at 10, exclusive because 10 is not included, and move in 2 steps. So it means you start from 2, from 0 plus 2, you have 2 plus 2, you have 4, and so on. And then you go to a step short of that, of 10. So if you run this now, you have 0, 2, 4, 6, 8. So let me do another one. Say I just come to a new cell and I say, I can call it anything. Let me just call it array now, whatever. Let me call it array and I say np.arrange, and I have this. Start from, maybe I just need, we did something like all the odd numbers before 50 the other time. So I just say start from 1 and then stop at 50. Stop at 50. Odd numbers are 2 steps apart, okay? So if I do this and I just come and I print array, so it means I'm going to have 1, 3, 5, and so on and so forth till I get to 49. And that's where it all stops. You can see that. So you can actually create a range like that. So you remember the other time when we're doing that, all the odd numbers before 50, we had to use like three lines to define a function or something. But here you can just use a range to create what you want. Okay. So you can also create an array of zeros and ones. I mean, there's something like this in MATLAB, which I've used before. So here now, you have zeros array. So you want to create an array of zeros. So you just say np.zeros. So zeros is actually a function inside of the NumPy library. So, and you want it to be a 2 by 3, you want it to be a 2 by 3 array. That's 2 rows and 3 columns. Then, of course, you also want to create an array of ones. So you have ones array. So that again, you have ones, which is also a function inside the NumPy library, which is a 3 by 2 array also. That's 3 rows, 2 columns. And then print zeros. That will print this 2 by 3 matrix, a 2 by 3 array with zeros. Now, this print in line 4 is just a blank print to give space between this and this. So I'll show you, if I don't have that line 4, what is going to happen. I'll show you very soon. So if you do this now, you see you have a two rows, 3 columns of zeros. And here you have 3 rows, 2 columns of ones, right? So you can see this space. If I don't have this line 4, for instance, if I comment it out, it means the space will be closed up and you may not really get the gist. So I put this. So anytime you want to create space between 2 results like that, you can put a blank print. Okay. So that's that. So those are ways in which you can create NumPy arrays. All right. So let's talk about array operations. NumPy is basically about arrays, which you hardly find when you're dealing with inbuilt Python data structures. So since it's about arrays and now know how to create arrays, what else can you do with these arrays? Of course, you're going to go in depth, afterwards. This is just like an introduction to NumPy. So I'm going to make other videos to focus on specific areas of NumPy. Like we are still going to talk about some of these array operations, indexing, slicing, and all of these things. But this is just like a general introduction to NumPy. Okay. So talking about array operations, NumPy arrays support element-wise operations, broadcasting, and various mathematical functions. So if you want to do element-to-element stuff, which is very common when you're working with matrices, for instance, right? Like if you want to add or subtract matrices, you do it element-wise. So in this case now, look at array one is, and so you're making a list into a NumPy array. First one is containing 1, 2, 3. Second one is containing 4, 5, 6, and then you now want to print array 1 plus array 2. That means you're adding element wise terms. So that's 1 plus 4 5, 2 plus 5 7, 3 plus 6 9. Then if you want to multiply element wise, you have array 1 times array 2. That's 1 times 4 4, 2 times 5 10, 3 times 6 18. And that is exactly what happens here. So we're going to go in depth when I make other videos on this, but this is just introducing us to the whole idea of array operations on a broad scale. All right. So look at what happens here. You have array, which is, so you're making this. You have array np.array. Now, what this is telling you is that you're going to have, this is row 1, this is row 2, because this is a list of lists, right? So you're making a list of lists into a 2 by 3 array, because it will be 2, this is row 1, this is row 2, and then each one has 3 columns. So you're going to get a 2 by 3 thing, and then you define the scalar too. So you now say print array times scalar. This is called broadcasting. It means you're doing the same operation over a whole range of a whole array of data. So it means you're multiplying each element of the array by the scalar. So it's a 2 by 3 array, and you're multiplying every term in that 2 by 3 array by 2, which is the scalar you define. So if you pull this out now, so you now see 2 times 1, 2, 2 times 3, 4. I mean 2 times 2, 4, 2 times 3, 6, 2 times 5, 8, 2 times 4, 8 rather, 2 times 5, 10, and 2 times 6, 12. Okay, so broadcasting, so it means you're doing one thing over a whole range of a whole array, right? Like that, right? Of course, we can also talk about index slicing. We can talk about index slicing. So not to worry if it looks like these things are short. This is just a general introduction. We're going to talk about deeper things under NumPy as we make other videos. Okay, so let's talk about indexing and slicing. Indexing actually talks about you pinpointing a particular element in an array, right? For instance, you have NumPy arrays. Okay, NumPy arrays support powerful indexing and slicing operations. Sometimes you want to do in your computation, you want to actually do something on a particular item, so you can actually index to get there. Then slicing talks about extracting a portion of an array, right? So here you have print array 0. So 0 here actually talks about, that's like in this array now, you have two parts, you have two components. You have the first row and the second row. So of course, in Python, it's like 0th row and the first row, because counting starts from 0 in Python. Then if you're talking about print array 1, 1, that's first row, comma, first row, comma, first column, first row, first column. And what that means is that, this is row 0 in short, and this is row 1. And then 1 1 means so this first row, first column means that you have this is 0th row, first row. Then in this first row, what is the first column? This is first 0th column, second column. So that means you are dealing with 5 here. When I run it, you'll understand better. And then when you talk about slicing now, you want to get, okay, let me just even run this and explain from that. Maybe that helps better. Okay, so we just say array 0. So from this array now, this is like 0, first 0 row, 1 row. So array 0 means the first row, and that's why you have 1, 2, 3 here. Then 1, comma 1 means, so if you look at, okay, maybe what I should even do first is I should print the array itself so I can refer to it easily. Print ARR. So then I also want to put blanks in between so you can actually get to see things more clearly apart. So you have this and you have this. Okay. This now and this. And then I run this. Okay, good. Now you see print array now. This is first 0th row, first column, 0th row, first row, 0th column, first column, second column. That is how it goes in Python, right? So when we say array zero, we are simply talking about the first row, what we'll see as the first row, which is actually the zero row. That's one, two, three. But when we say 1, 1, right, this is uh row one, column one. So this is row zero, this is row zero, this is row one. So in this row one now, we also talk about column one. This is column zero, column one. And that is why that falls on five. So row one, column one, that falls on five. And that's why the result here is five. Okay. So look at what is happening next now. We are picking, so here, want to pick so here we are slicing all rows from the second column onwards. So this full dot here talks about slicing all the rows, but then you're starting from the second column onwards, because one upwards means that you're starting from, zero is the first row. So, but the first uh zero is the first row, right? But the second is actually one, because counting starts from zero. That's why you have here 2, 3, 4, 5, 6. And that's exactly what you have here. Never mind, if it's not so clear now, we're going to make a whole video on just talking about these array operations of slicing and indexing. Okay. All right, let's talk about array manipulation. So NumPy provides functions to manipulate arrays. For instance, you can reshape arrays, So you can say array equals np.arange 1 to 10. So if here we have not put, because there's no third part to say we are moving by 2, so it automatically means that we are incrementing by 1, but then it starts from 1 and it stops at 9. It doesn't go to 10 because 10 is always excluded, okay? So that's what that is going to do for you. So this is going to print, so this array is just going to be from 1 to 9, okay? Then, knowing that we have 9 elements, that you can easily reshape it. So any reshaping you are doing, by the time you multiply 3 times 3, it should be exactly equal to the number of items you're going to have in the array. From 1 to 9, this is a range from 1 to 10, right? That means you have 1 to 9. That's 9 items. So if you are reshaping it, you cannot do 3 by 4, but for instance, because 3 times 4 is 12. So anything you're doing, it can be 1 by 9, it can be 9 by 1. In fact, let me even do all, okay, well, I can do that later. So here we are doing 3 by 3. So it means you're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. That's exactly what's going to happen here. Okay. So any reshaping you are doing should be according to the number of elements you have. So we can do 1 by 9, we can do 9 by 1, because that's what we have. So here now I can have 1 row, 9 columns. And then if I run that, you see what we have. Then we can have 9 by 1. That's 9 by 1. That's 9 rows, 1 column. That'll be vertical. And that's exactly what you have here. So any reshaping you are doing should be according to the number of items you're supposed to have in there. Okay. So for instance, if you have a 2 by 3, if you have a 2 by 3 array, you can make it into 3 by 2, 6 by 1, 1 by 6. By the time you multiply the number of row and column, it must not be more than the total, the product of the row and column you started with. Basically, we are going to go in depth into that. So you can also transpose arrays. Transpose means the rows becomes columns, the column become rows. If you have a 2 by 3, it becomes 3 by 2 when you transpose. So here now you have an array which is of a list of lists, so 2 rows, 3 columns. So this is a 2 by 3 thing. But so this line 3 is saying transposed array. So you now say array arr.t. So this T now is the transpose of what you're doing. And then by the time you do that, this is a 2 by 3 thing. So it will now become 3 by 2. And that is exactly what you get. So you see, it was 2 by 3 before, then it becomes 3 by 2. So you go 1, 4, So normally it should be like, let me, so if you, okay, let me print the first one actually, so you get to see what I'm talking about. So you have print, print, print ARR, print ARR, okay? And then, this goes with this, and then you transpose, and then this goes with this. So we can put a blank print in between to separate the two so we can see how the transformation takes place. So run this now. You see, this is the initial 2 by 3 matrix. So, and for transposing now, the rows become column. In fact, I have a whole playlist on matrices like normal matrices, not talking about Python now, normal matrices in math. I think I have up to 26 videos in that. So you can check the playlist out on matrices. So I talked about different concepts, including transposition. So the transpose of a matrix. So here the row becomes column. So row one becomes, oh, sorry. Well, I mean, this Python counting thing. Row zero becomes column zero. Row one becomes column one, basically. In the same way, you can also look at it in terms of the fact that column one becomes row one. I mean, column zero becomes row zero. Column one becomes row one. Column two becomes row two, like that. Don't forget we're counting from zero. So that's how that goes. And then we talk about mathematical functions. So, I mean, one beautiful thing about NumPy is that you can perform mathematical calculations on a whole array. For instance, you have this array called, you made this list 0, 30, 45, 60. It looks like special angles, which I've also treated under trigonometry. I have a playlist on trigonometry, so you want to check that out. I did the special angles like 0, 30, 45, 60, and 90. So you have an array 0, 30, 45, 60, 90, and then you want to make some calculations on this whole array. For instance, you want to find the minimum value of this array. So you just say print np.min. This min, minimum, is actually a function inside of NumPy. So you want to find the minimum value of this array. Because we are saying that this is just 590, it's easy to see the minimum is 0, So here we just know the minimum is already 0, and so on and so forth, right? Then the maximum, that's 90. You can find the sign of all the sign 0, sign 30, sign 45, and so on. You get all the values. You can find the mean of the whole thing. That's going to be one value. This is one value, one value. Sign is going to be sign for each one. Then mean, you can find the mean for each one. You can also find the standard deviation. I mean, the mean, it's just one value. So sum up everything and divide by 5, right? So let me also do cos and tan, right? See, let's go. This apart from sine, we can have cos. Then apart from that, we can have tan. Okay. So I just want to do all that. Tan. Okay. So by the time we run that, see, we get everything. So the minimum is 0, the maximum is 90. Then if you find the sign of this whole array, that's like this value, sign 0 is 0, and so on and so forth. Then the mean, if you find the mean of that, that's 45. If you find the standard deviation, that's 30. And with that, this is just an introduction to NumPy, which is numerical Python. That's why this video is titled Numerical Computing with NumPy. So in videos that follow this, I'm going to go deeper into some of the things I've already discussed here. So at this point, if you have not subscribed, you want to be sure to do that. Don't forget to subscribe. And of course, hit the notification bell so you can always get alerted each time I release a new video. And of course, your comments are welcome. If you want me to do something, maybe teach a topic in math or in numerical scientific computing, maybe a particular algorithm or something, you can talk about it. You can like and also share. Then don't forget the notes are available in the description box so that you can, and the essence of that is you download and then you can tweak the codes and, just play around with them. So by doing that, that was how I was able to really learn. When I started learning, I was watching tons of YouTube videos, and then by the time it was time to practicalize, it was really difficult. But with you having access to these notes, you can actually, in fact, you can even download the note first before you start working with the codes, and then as I'm doing it, you can tweak it and do your own thing. Any curiosity you have, you can check them out. So thank you so much for listening. Watch out for the next video. Thank you so much. Yes, stop.